Assalamu alaikum, my dear students. I hope you all are fine. Welcome back again with the new video lecture on electricity. Our discussion will be on the topic effects of factors affecting the resistance of a conductor. How the resistance of the conductor affects, what are the factors which affect the resistance, or on what factors the resistance of a conductor depends. So this will be our topic today. There are three main factors on which resistance of the conductor depends. One is first one is nature of the conductor. Okay, how is conductor, or what is conductor made up of? Okay, what is conductor made up of, or which material is used in the conductor? This is the nature of the conductor. And second one is length. Length of the conductor. What is the length of the conductor? Okay. And third one is area of cross section. Third one is area of cross section. What is the area of cross section? So these are the three factors on which the resistance of the conductor depends. And there is also the fourth one, that is temperature. What is the temperature of the conductor? Okay, but these are the three main factors on which the resistance depends. First one is nature of the conductor, second one is length of the conductor, and third one is area of the cross section. Firstly, let me discuss this length of the conductor first. Effect of length of the conductor. Okay, the resistance, for example, we denote the resistance with R, capital letter R. This resistance is directly proportional to the length of the conductor. Okay, as the length of the conductor increases, for example, this is for example, consider it as a copper wire with length 1 meter. Okay, if I bring the 2 meter length copper wire, the resistance will be more here. Okay, that means this resistance increases with the length. So it is directly proportional to the length of the conductor. As the length of the conductor increases, the resistance also increases. Okay, so we can write it as R is directly proportional to L. Okay, R is directly proportional to the L. Resistance is directly proportional to the length of the conductor. As the length of the conductor increases, the resistance of the conductor increases. So this is the cause that long electric wires offer more resistance to the electric current. And then area of cross section. How is area of cross section? How it affects the resistance? Resistance R is inversely proportional to the area of cross section. Okay, as the area of cross section, for example, this is the area of cross section of this wire length L. For example, this is the length L. Okay, if I increase the its area of cross section, for example, if I increase its area of cross section like this, and L is same. Okay, if L is same, here the resistance will decrease. Okay, here the resistance will decrease because its area of cross section increases. So resistance R is inversely proportional to the area of cross section. As the area of cross section increases, the resistance will decrease. As the area of cross section decreases, the resistance will increase. Okay, this means that R will decrease with increase in area of conductor, and and vice versa. So I can say that R is inversely proportional to area of cross section. If A is area of cross section, so R is directly proportional to 1 by A, or we can say, we can read it as like this: R is directly proportional to 1 by A, or R is inversely proportional to A, where A is area cross section of the conductor. And third one we talk about was nature of the conductor. So what is the effect of nature of conductor on the resistance? The electrical resistance of the conductor depends on the nature of the material of which it's made. For example, copper offers one resistance, and iron offers some other resistance, okay, and aluminum has some other resistance, okay. So the resistance depends on the nature of the material, what is material made of, okay. The resistance depends on the nature of the material, and different materials have different resistances, offer different resistances. Some material have low resistance, while other have high resistance, okay. So from the above equation we have R is directly proportional to L, length, and R is directly inversely proportional to area of cross section. So if I combine these two, if I combine if I call this as first and this as second, if I combine these two, I will get R is directly proportional to L divided by A. This is the combination of these two equations. R is directly proportional to L, and R is inversely proportional to A. Here both equations are combined. R is directly proportional to L by A. So if I eliminate this proportionality, so here comes the proportionality constant. R is equal to rho L divided by A. This is a Greek letter. It's called rho, okay. So this is rho, R-H-O. This is a Greek letter. We name it as rho. This is the constant of proportionality, and is commonly called the electrical resistivity, okay. So this rho is electrical resistivity, or we call it as specific resistance, okay, or specific resistance. And its magnitude depends on the nature of the conductor, okay. So this rho or electrical resistivity will depend on the nature of the material. What is material made of? Is it copper? Is it zinc? Is it iron? Is it something else? So it will this rho electrical resistivity will depend on the nature of the material. One more thing, or one more factor is there on which the resistance of the conductor depends, is the effect of temperature. That is, the resistance also depends on the temperature of some material. So effect of temperature. The resistance of the conductor generally decreases with increase in temperature. As the temperature increases, the resistance will also increase, okay. The resistance will also increase. This is resistance R, this is temperature T. As the temperature increases, the resistance of the conductor will also increase. And it has been found that the resistance of all pure metals, this is pure metal, pure metals increase with the rise in temperature. If we rise the temperature, the resistance of the pure metals also increases. However, the resistance of alloys like magnesium, constantan, and nichrome are almost unaffected by temperature, and practically does not increase with rise in temperature. So there are some alloys like magnesium, constantan, and nichrome which are not affected by the rise in temperature. So generally, if we talk about the pure metals, the the temperature affects the pure metals as far as resistance is concerned, and it will increase with the rise in temperature. So let's now try to explore the reason why, with increase in area, with the increase in length of the conductor, why the resistance increases, and with the decrease in with increase in area of cross section, why the resistance decreases. Let's explore this reason with the logical explanation. For example, हमारे पास एक conductor. So this is the conductor, and we know that every material is made up of atoms. सभी material atoms का बना हुआ होता है, and there is a specific arrangement of these atoms. Okay, तो वहाँ पे कुछ specific arrangement होता है atoms का. That arrangement is called LEDs. For example, इसमें four atoms. मान लो four atoms. 1, 2, 3, and 4. And there is a specific arrangement of these atoms. ये देखिए यहाँ पे एक arrangement है in atoms का, and this arrangement is called LEDs. तो atom में या material में कुछ free electrons भी होते हैं, ठीक है ना, क्योंकि हमें पता है कि electrons atom के around revolve करते हैं. So there are also free electrons which are not bound. For example, यहाँ पे 2 free electrons है, ठीक है ना, इसमें 2 free electrons है. And these electron, free electron, are the cause for the electric current. यही electric current produce करते हैं. These are the cause. So जो electrons bound होते हैं वो जो है they are not cause for the electric current. So these free electrons are cause for the electric current. For example, there are two free electrons. हम ये जानने की कोशिश करते हैं कि as the length of the conductor increases, how this resistance increase. Okay, for example, this is length L. पहले इसकी length L है, ठीक है ना. इस L length में four atoms है, and two electrons are there. Okay, so जो ये जो electron, when these electrons travel, जो ये travel करेंगे, तो यहाँ पे ये atoms जो हैं ये इनको इन free electrons को attract करेगा, because we know that atom contains the protons. इसमें proton भी होते हैं और neutron भी होते हैं. न्यूट्रॉन को आप छोड़ लीजिए, उसका जो नेट चार्ज होता है that is zero, that's neutral, इसलिए उसको न्यूट्रॉन कहते हैं. तो इसमें प्रोटॉन्स भी होते हैं. प्रोटॉन्स का चार्ज प्लस होता है, प्रोटॉन्स का चार्ज पॉजिटिव होता है, और इलेक्ट्रॉन का चार्ज नेगेटिव होता है. और ऑब्वियसली these protons will attract these electrons. So this electron will be attracted by this atom, and this electron will be attracted by this atom. And if when they travel, if there is no potential difference, अगर यहाँ पे कुछ net potential difference नहीं है, तो ये attract हो जाएंगे. अगर यहाँ पे net potential difference create हो रहा है, तभी ये electrons travel करेंगे, तभी ये electrons travel करेंगे. और अगर यहाँ पे net potential difference है भी, तो यहाँ पे इसकी जो है net पोटेंशियल डिफरेंस 1 होगी, और जब ये यहाँ पे पहुंचेगा इस एटम पे, ये एटम भी इसको ड्रैग करने की कोशिश करेगा, और इस एटम को भी इस इलेक्ट्रॉन को भी ये वाला एटम जो है ड्रैग करने की कोशिश करेगा. यानी कि इसकी नेट जो काइनेटिक एनर्जी है, यहाँ पे इसकी काइनेटिक एनर्जी और यहाँ पे इसकी काइनेटिक एनर्जी रिड्यूस हो जाएगी, ठीक है ना, इन अट्रैक्शन की वजह से. तो जब इसकी लेंथ जो है इंक्रीज हो जाएगी, ठीक है ना, लेंथ इसकी इंक्रीज हो जाएगी, तो यहाँ पे एटम्स और आएंगे, ठीक है ना, एटम्स जो हैं और ऐड होंगे जब लेंथ इंक्रीज होगी. तो जब भी इलेक्ट्रॉन यहाँ पे पहुंचेगा, तो ये एटम भी इसको अट्रैक्ट करेगा, ये एटम भी इस वाले जो है इलेक्ट्रॉन को अट्रैक्ट करेगा, और यहाँ पे भी ऐसे ही होगा. तो जो लेंथ ऑफ द कंडक्टर इंक्रीज हो जाएगी, तो काइनेटिक एनर्जी ऑफ दिस इलेक्ट्रॉन विल रिड्यूस. ये जो काइनेटिक एनर्जी है रिड्यूस हो जाएगी. तो इसका जो फ्लो है वो भी रिड्यूस हो जाएगा, और जब फ्लो ऑफ इलेक्ट्रॉन्स रिड्यूस होगा तो ऑटोमेटिकली द करंट विल डिक्रीज।